You're listening to Masonry Principles, your guide to building better buildings, with hosts Amanda Bedian and Phil Leden.
All right, welcome to Masonry Principles. Today's episode will be focused on sustainability, specifically in the cement industry. And so with us today, our guest is Claude Bergeron, who works with Holcim. And Claude is the Technical Services Engineer for the Great Lakes region. Claude has been involved in this for quite some time, so we wanted to have him on today to talk specifically about Portland Limestone Cement and some of the short-term goals and strategies the cement industry is taking to promote sustainability, and also what their long-term sustainability goals are. And so with that, Claude, welcome to our podcast. And do you mind just giving us a little background and just a little insight on where you see the cement industry going in terms of sustainability?
Well, good deal. Thanks for inviting me, Phil. I'm happy to give you some insight. What this is actually, it's a transition. The cement industry is transitioning away from ASTMC 150 Type 1 to Portland cement to an ASTMC 595 blended cement. And it is kind of a big deal. It's kind of a big deal from specification standpoint. And what this transition is about is, the concrete industry is it's really been in the crosshairs of a lot of people lately. And I shouldn't even say lately, but I guess what I mean is when you look in the news, I'll bet you a month doesn't go by where there's not a story, on the radio or on TV or something about the concrete industry, or I should say the cement industry in general, because the cement industry produces CO2 is what I'm trying to say. And when we produce clinker, which is a product that we then grind into Portland cement, the production of this clinker produces carbon dioxide. And, carbon dioxide has been identified as a greenhouse gas. And, what is a greenhouse gas? Well, a greenhouse gas has been identified as a gas that traps heat and radiation in the atmosphere, which then warms the surface of the earth. So, as an industry that produces CO2, like I said, you can imagine, it's an industry that garners a lot of attention, like I said, in the media. So, the industry for many years now has been working toward trying to reduce our CO2 output and, quite frankly, stay off of everyone's radar, I guess. So what we're really doing is a transition to try to reduce our CO2 output at a cement plant.
So I guess in terms of raw numbers, I mean, we're moving from Portland cement, like you had said, the ASTMs for that to this Portland limestone cement. And so how does that, I guess, reduce our carbon footprint, or what type of magnitude does that have on our overall output?
As far as the magnitude, or I guess maybe to back up, to maybe just give you some numbers, or to get kind of put things in perspective a little bit. In 2020, the United States estimated that we produced approximately 90 million metric tons of clinker. And for every ton of clinker, we produce approximately, it's not exact, but approximately 1 ton of CO2. So in the United States, if we produce 90 million metric tons of clinker, we produce approximately 90 million metric tons of CO2. The world, however, is estimated 4.1 billion, that's billion with a B, metric tons in the same year, 2020, of clinker. So the world put out 4.1 billion metric tons of CO2. China leads the race there at 2.2 billion metric tons, and India is second at 340 million. So I'm just trying to give you an idea of how much CO2 is being put up into the atmosphere due to the production of clinker. So again, it's the idea of the production of clinker that produces a CO2. And when we produce clinker, what we're doing is we're burning fossil fuels. If I showed you a picture of clinker, it looks like a bunch of burned up marbles. What it is we introduce limestone and clay and things like that into a kiln, and then we heat that kiln up to approximately 3,000 degrees Fahrenheit. So very hot. We turn it into a molten state. And in doing that, we burn fossil fuels. And so that's where we create our CO2.
Okay. So the CO2 is a function just of creating that molten clinker just through the process. And so it's through the heating of those furnaces at 3,000 degrees Fahrenheit. I guess I didn't realize that was where the bulk of the CO2 was being produced, but I mean, that makes total sense.
Exactly. So when we produce 1 ton of clinker, like I said, we're producing, approximately, it's not exact, but approximately 1 ton of CO2. So that's the real problem. So what we're seeing on the horizon, well, there's something called the Buy Clean movement. And what this is a movement sponsored by government agencies and private companies where people are demanding low carbon energy sources and climate friendly processes in their supply chains. And in order to meet the demands of these types of requirements, the cement industry says, well, you know what? We need to make changes in our manufacturing. And this whole transition is about the cement industry looking to make these changes like I said, to basically reduce our CO2 output. I guess I'd say, furthermore, there's something called the Clean Future Act, and it was part of this past Congress. It has another name. It's the Leadership and Environmental Action for Our Nation's Future, kind of a long-winded title there, but what it basically says is every federal agency must develop a plan to basically show how what they're doing to reduce greenhouse gas emissions to at least 50% below 2005 levels, for example. As we see this philosophy of, hey, how what can we do to reduce CO2 output? Naturally, the cement industry, we realize, based on those numbers I gave you a few minutes ago, we need to make some changes within our system as well.
And so, in terms of cement, I mean, obviously, the masonry industry, we use an awful lot of cement, whether we're manufacturing concrete masonry units. Obviously, we have cement as a part of our grout mixtures as well as our mortars. I mean, in terms of our mortars, we often talk about Portland cement. Is there a difference in much of the CO2 output from maybe a masonry cement versus a mortar cement versus a Portland cement lime mortar, or are they all kind of the same?
Yeah, that's a good question. What I'm talking about is really isn't going to affect the masonry mortar industry. So if someone is going to be working with a type N, S, or M, this isn't so much going to affect them. Those products are, for the most part, going to be made very similarly. So the transition does not really affect those products. However, grout, which is indeed made with type 1, that industry, this transition will definitely affect production of grout. Or not, I shouldn't say affect production of grout, but grout will be produced with a ASTMC 595 product as opposed to an ASTMC 150 type 1 product.
And in terms of performance, I mean, I know I've read through a little bit of the testing data and ASTM C595, that PLC kind of replacement. I mean, you're not seeing any changes in terms of strength or any other performance requirements from what I've gathered. Is that correct?
Yeah, that's correct. What's really happening is it's more of a specification issue. And so I guess I should explain a little bit more. So why are we transitioning away from ASTM C150? Well, ASTM C150 is the specification that we use for type 1 Portland cement. And if you look in C150, in the ingredients of C150, you'll see that there's a section in there that says you can put limestone into like 1 ton of clinker. You can put up to 5% just limestone. So what I'm getting at is this: for, say, I think about the past 10, 12 years or so, what cement companies would do is, we knew we needed to reduce our CO2 output. So what we would do is, since ASTM C150 allowed up to 5% limestone, I told you that producing clinker is what created our CO2. So we would, instead of basically selling 1 ton of clinker, we would sell like 95% clinker product. So 95% of the product went through the kiln. 5% of that product was just limestone. It was ground limestone that did not go through the kiln. So if you had a plant that, let's say, made 2 million tons of clinker, well, you were able to save 5% of 2 million tons of CO2 from going up in the air. If you're still following me, I hope. So C150 allowed you to put 5% ground limestone in with that clinker material. Well, we've decided that as an industry, we want to put even more ground limestone into 1 ton of clinker. But C150, like I said, it limits how much you can put to 5%. Let's say we want to put up to 15% limestone and save ourselves even more CO2 output. Well, then you need to go to a specification called ASTM-C 595. And in that specification, it says the Portland Limestone Cement shall be more than 5%, but less than or equal to 15%. So, getting back to that 1 ton of clinker, when we produce that clinker material, we're burning fossil fuels. Well, now we're going to burn, say, we'll use 10%. In 1 ton of clinker, it's going to be 90% clinker product, 10% ground limestone. A 2 million ton plant, well, you're saving 10% of its CO2 from going in the air. That's why we're transitioning away from C150 and now we're transitioning to C595.
So yeah, that makes total sense. So, I mean, we're talking about reducing the overall carbon footprint. And I mean, even though, we're talking 5-10% might not be a huge percentage when we're talking 5% of 9 million, or whatever we were talking about at the beginning, that's a lot of CO2 that we're limiting. I think, I mean, in terms of who listens to our podcast, our audience, I mean, we have a lot of architects and engineers that listen in here. I mean, I think the big change for them, and correct me if I'm wrong, is that they're going to have to start going through their specifications and updating their concrete and masonry specifications to include C595 in lieu of older ASTMs, because quite frankly, those cement products just might not exist anymore.
Absolutely. You're right. I think one of the difficult things is anyone who went to school over the past 100 plus years, learned about ASTM-C 150 Type 1. That specification is so old and maybe so well respected or so well used that it's the standard that everyone knows. But the reality is, one thing that the cement industry did for the past several years, it's been working to get ASTM-C 595 to appear on par in all the codes. So if you look in International Building Code, if you look in Master Spec, if you look in all of the whatever code book you're using, ACI, all the ACI documents naturally, you're going to see ASTM-C 595 is going to be listed right next to ASTM C150. I think that was one thing the cement industry did. We anticipated this, and as far as a code standard goes, it took a lot of work because we had to go to all these agencies and show them the science behind what we're doing. I kind of brushed over it, but quite frankly, I told you a few minutes ago, in 1 ton of clinker, I'm using 10% as a round number, but for many years we were using 5% limestone and that met C150. Now we're going to put 10% limestone and that's going to meet C595. Someone may say, well, wait a minute, you're putting sawdust in the hot dog, right? We can talk in a few minutes about the science behind it, why it actually has improved both the plastic and characteristics of the concrete. From a designer's perspective, in all of your specifications that you put out now, you need to recognize 595 because your building won't be able to get built anymore because simply C150 Type 1 is becoming quickly unavailable.
Huh. Yeah, so that's really good for us to note. I mean, oftentimes we see specifications not getting updated on a regular basis. I actually just saw a set of drawings that referenced, I think, the 2006 six IBC here in Michigan. So I mean, about 20 years outdated there. So that's something that we will have to be aware of moving forward. And yeah, I mean, I'm curious to get in the science behind it. So performance wise, I mean, how does it react differently?
Well, what the Portland Cement Association did a number of years ago is they hired some of the best minds in the industry and they kind of did an analysis. Well, I guess I should explain this idea of putting limestone into the clinker. This is nothing new. Europe has been doing this since actually the 1970s. And Canada, for example, has been doing this probably 8, 10 years, maybe. So the science has been out there, the technology has been out there, the understanding of it has been out there because of the way documents work there. Their transition has been, just a little bit quicker and easier. What do we know about, putting limestone into the clinker? How on earth can that improve both the plastic and hardened characteristics of the cement? Well, there's a couple of things, and I guess what I would say is there's one thing called the particle packing effect, and so what we're doing here is if you can imagine the ground limestone, it's smaller than the cement particles. So, kind of in a nutshell, it works as a the idea would be, let's say you had a bunch of golf balls and a bunch of marbles. You put them into a large box or something, but then if you put in a bunch of BBs and then shook the box up, those BBs would then kind of help create a tighter matrix of material, right? So that's kind of the idea of what's happening with particle packing, where the matrix of your system becomes a little denser. The pure particle packing effect of the limestone creates a better matrix, both in the plastic and the hardened state. Another positive aspect of the ground limestone is something we call nucleation effect. And what that is that's going to kind of be hard to explain without some pictures, but it's the idea of these small particles, this limestone. When the cement gets hit with water, it creates a paste, and that paste needs to cover every particle in our mix. So every sand particle, every stone particle, needs to get covered with this. It's almost like a toothpaste kind of gel. And the fine particles of the limestone, they almost act like a bridge where the paste kind of goes further. The paste becomes more economical, or it just allows the paste to go further into the matrix and cover things better in the matrix of the system. So those are two examples of how we actually see this ground limestone being beneficial. Again, both in the plastic and hardened state. So it's really remarkable when you start looking at compressive strengths and things like that. Even the plastic characteristics, it becomes a little more fluid for the contractor as well. So it has been accepted positively throughout the industry.
And so, I mean, talking about the cement matrix, I mean, really, it's only going to affect grout and the manufacture of concrete masonry units in regard to the masonry industry. So, I mean, with an improved matrix and that kind of fluid flow you were talking about, is that going to actually help us in terms of water resistance as well? Because I'm assuming if our matrix is more filled instead of voided, I mean, there might be improved water, not water absorption, but water repellent characteristics. Has there been any testing to that effect?
Yeah, exactly. You make a good point. So I think, like I said earlier, our mortar joints, like again, the M, the N, the S, these types of things, this transition does not affect them. But certainly, we would expect to see improvements in perhaps CMU production, just like you said, because the idea of particle packing, the idea of nucleation effects, it makes a less permeable matrix. So believe it or not, these are some things that we would hope to see translate to the product industry as well, whether it be CMU or any type of product, really. Absolutely.
Okay. So I mean, this is a national effort, right, from the cement industry. I mean, it's not just Michigan. This is the whole country that's kind of moving towards C595 and other sustainable options.
Like I mentioned earlier when we started speaking, this Clean Future Act that was, it was passed in the 2021-2022 Congress. There was talk about this. People who had their ear to the ground knew this type of thing was coming. So not only is the Clean Future Act a federal act, but we've seen states and even cities enact policies regarding this whole idea of buy clean movement. So what I'm getting at, for example, take like the state of Texas. We have plants in Texas that transitioned a number of years ago. We have plants out in Washington, the state of Washington. They transitioned a few years ago. Colorado as well, because they actually had legislation on the books that was, saying, if you want to provide, cement on these government jobs, you need to show that. Well, we didn't get into something called the global warming potential, but there's something called the GWP, and it's a matrix where we can put a value to products, and based on their CO2 per kilogram equivalent. Some states in the United States have already adopted some of this philosophy. Some states have had to transition much sooner than the Michigan area, for example. So this is happening all over the United States. Like I said, Canada, for example, has transitioned many years ago. Europe transitioned, way even before that. I can tell you, our plant here in Michigan, we transitioned January 1. I know other plants that are not Holcim plants, like our competitors, they too have been transitioning, literally as we speak. It's certainly happening across the country, and it's certainly a movement that you need to be aware of.
Okay, well, yeah, I think we covered everything I wanted to cover as far as PLCs. I mean, just getting the word out there, that these are out there. They are, the future. They are the present actually, and that's what we're making. Throughout the U.S. And so, Claude, thank you very much for your time today. I really appreciate you kind of going through everything for our listeners, and hopefully, it gives them some good information, and if nothing else, they can revise their specifications. And if anyone has any questions on PLCs or kind of cement industry, where it's going, you can always reach out to me at the Masonry Institute or any of our members, and we can definitely get you more information on it. So thanks for listening, and have a great day.
Thank you for listening to this episode of Masonry Principles. To continue the conversation, be sure to reach out to us by visiting masonryprinciples.com.